Hi, my name is Dr. Ambikesh Jayal, and I have created this tutorial for simple regression modeling. Uh, in this tutorial, we would be using Boston housing dataset, which has been downloaded from this website. Um, Originally, this dataset has got 14 columns, as you can see, so variables like per capita income or tax. What I have done is I have slightly modified this dataset by introducing three new categorical variables. So I'm going to show you this dataset in a CSV format. Okay, so this is the dataset that we will be using for the tutorial. And there are some columns, as you can see, highlighted in yellow. One column highlighted in uh, green and one in blue. And the column highlighted in yellow are our independent variables, whereas the column highlighted in green and blue are dependent variables or target variables. The hypothesis is that the variable MDEV and investment risk are dependent on the yellow variables, which means we should be able to calculate MDEV and investment risk from the variables in yellow. So the task is to build a model. The input to the model will be the variables in yellow, and the output of the model should be the MDEV for regression modeling because it's a continuous variable. And for classification tasks, the output of the model should be investment risk because it's a categorical variable. And so once you build what the model should be able to do is, if I give the model this row number 2 without the corresponding MDEV and investment risk, which have been highlighted in yellow, then the model should be able to predict these values. Sometimes model will get it right, sometimes model will get it wrong. And the aim is to build a model which has got a high prediction value, or which is more accurate. Okay, I'll go back to my Google Colab worksheet. In this tutorial, I have given you some useful links as well. So the first very useful link is Pandas cheat sheet, which is here. And it explains a lot of functions which can be used in dataframe. So dataframe is a bit like reading an Excel sheet. So it has got column names, row names, and the values. And I have given some other links, for example, link to read more about pandas, RandomForestRegressor, which is used in the regression modeling, RandomForestClassifier, which is used in classification modeling, and how to view a decision tree, and the Boston housing dataset. So let's jump on to the task. And these are the 6 steps that we will be doing in this tutorial. So the first one is reading the data using pandas data frame, and this task simply reads the Excel file into a variable. So reads all this Excel file into a variable. The second task is data cleaning, which will take care of things like missing values, and then data exploration, feature selection, and then splitting the data into training and testing sets, building a model, and checking the performance. Okay, so this is the first task, which is step 1, which is reading the Excel sheet or CSV file or data basically. So data could be from a URL, which is line number 6. Data could be stored in a local CSV file, which is line number 10. So at the moment I have commented out the line number 10. But if your data is in a CSV file locally stored, you have to uncomment line number 10 and give it the complete path. So at the moment I have stored the data in a URL, and I'm reading the URL line number 6, and line number 7 is simply using pandas data frame read CSV function to read the content of the data into a data frame. So now I'm going to run it by clicking on this button. So when I run this pandas, so line number 12 prints the data type of the variable. So the data type is pandas data frame, and the line number 13 prints the data. Data contents of the data frame. And as you can see, data frame is basically your Excel sheet. So it has got column names, row names, and the values in between. And there are 452 columns and 452 rows and 17 columns. So the number of rows in this Excel sheet should be 452. This 452. It's 53 because the first row is the name of the column. So it's 452 rows, and number of columns is 17. Okay. Okay, so that's first task done. The second task is to just get some info about the data frame. So when I run it, so if you wanted to get all the columns in the data frame, you could just say df.columns, or if you wanted to get the index values, you could say df.index, or if you wanted to get the values in the data frame, you could just use the df.values command. And df.info, it shows all the variables. So there are 16 variables here. And there are 452 values in each variable, and they are not null. So that means none of these variables has got missing values basically. If your data had missing values, let's say the crim had one missing value, then you will see 451 value here as not null. So these are all the indexes, the column names, and these are all the values on the data frame. So just basically more info about the data frame. Okay, data cleaning, we don't really require any cleaning in this data set because it doesn't have any null values. But this function will count the number of null values in each column. So when I run it, you can see none of the columns have got any null values. But if you had null values, then you need to deal with the missing values. So this one function df.drop na. It will delete the rows which have got any missing value. If you wanted to in Google Colab, if you just hover over the function, then it will give you the details about the function, that it removes the missing values, and it's yeah, more details about it. In your Pandas cheat sheet, there is this drop NA, which is drop rows with any column having NA or null data. Okay, the third one is data exploration. So I just want to describe the data and draw some plots. So when I execute this, you will see this basic stats about all the columns in the data. So for example, count, so how many points are there, mean, which is average, standard deviation, minimum, maximum, 25, 50, and 75 quartile. And so it gives you all the different stats about the columns. The box plot is here, so it just basically shows you the box plot. So these are your outliers, and then histogram gives you draws the histogram for each of the column values, each of the columns. Okay, this is a little bit more of data exploration. So what this does is it will generate a heat map. It will generate first the correlation. It will calculate the correlation matrix and then generate the heat map. What correlation does is, so if you click on this, just hover over this, it will tell you more about this function. So it computes pairwise correlation of columns. And what correlation means is how strongly two variables are related. So for example, you can see, of course, crim is related to crim. So the correlation coefficient will be 1. By the way, we are using Pearson coefficient here. And if I just hover over, so you got different methods that you could have used. Pearson and Spearman and others, but we are using Pearson in this code. So this is your correlation matrix. So let me just pick up. So if you see the value for this value, which is between tax and crim, you can see the value is 0.8. So the correlation matrix, the value is always between -1 to +1. And if the value is 0, that means both variables are not related at all. If the value is 1, that means they are positively correlated, which means if one increases, the other increases as well. If it's closer to -1, then it means both variables are related, but they are negatively correlated, which means if one increases, the other decreases. Crim and tax are positively correlated, which means if crim increases, the tax will increase as well. And this is the heat map, and you can see the heat map. So this is blue, which means these are highly positively correlated. And if I pick up this one, which is LSTAT and MDEV, it's highly negatively correlated, which is -0.7. So it's highlighted in a dark reddish color here. So that's the heat map. You can see the heat map here as well, so which is quite intuitive. Okay, next comes the feature selection. What feature selection means is that which variables do we want to include in our model? So as you can see, there are lots of variables in your data set. In this, the line number 5, what we are saying is for the independent variables, we will just include all these variables listed here. So crim, Zn, Indus, RM, age, and so on and so forth. In your data set, you may want to include some variables and exclude some other variables. So depending on the kind of data set you have got. And the independent variable, so then line number 5, I select my variables. Which variable do I want to include in the predictive model? And the rationale is that if, let's say, I don't think, for example, age will have any impact on the investment risk, then I will exclude the age from the independent variable list. Okay. And then line number 14, line number 6, then I'm from the data frame, I am reading all the columns which will be independent variables. So X will then be a data frame which will have only these columns. Okay, so I'm going to run it and show it to you. So this is my X. So as you can see, X has only the columns which are independent variables. And then my target variable, which is the variable that I want to predict. So in this case, it's MDEV. So I just store the value in MDEV in a target variable. And then, from the data frame, I just extract that target variable. So that becomes my Y. Y is a series object, by the way. So this is Y is a Pandas series. And as you can see, this is my Y, which is, it just got the MDEV variable. Length being 52, that's the number of rows in the Excel sheet. And then I convert my X and Y into NumPy array. The reason I convert into NumPy array is NumPy makes things very fast. So, that's a thing which is highly recommended. So I convert it into a NumPy array instead of data frame. So, okay, so then then comes this step, which is data splitting. So I split my data set into training and testing. So the line number 3, what I'm doing is I am splitting my data set into 80% and 20%. So the 80% being the training set and the 20% being the test set. Okay, then comes the next step, which is actually building the model. And again, it's quite simple. So I import, because it's a regression task, because what we are trying to predict is a continuous variable, which is mdev. And so I'm using the random forest regressor. So line number 4, I create the random forest regressor. Line number 3, I'm saying how many trees should I generate. So the way random forest works is it generates a lot of decision trees, and then it gets an output, get a predicted value from each decision tree, and then whatever the average is, that's your outcome. So rather than depending on just one decision tree, random forest has got quite a few decision trees. So we are saying we want 5 decision trees, and there are different parameters that you need to pass to the random forest regressor. And I have included a link for the random forest regressor here. So do go through these, because this page has got all the information about what the parameters mean. So for example, n estimator means the number of trees in the forest. So how many trees do you want in the forest? If you don't put any value, then it will default to 100. I've given it a value of 5. Um, um, the other variable is to set as max depth, which is the what should be the maximum depth of the tree. And I have set it to 8. But of course, you can set it to a higher value. Don't set it too high, because then that may lead to overfitting. Don't set it to too low, because that may lead to underfitting as well. And so this is you have to find the right balance here. And you could use things like hyperparameter tuning to find out the optimal value. Max features is I have set it as 6, but you can read about max features here. And what max features does is it's the number of features to consider when looking for the best split. So that's what the decision the random forest would do, that when it's trying to figure out um, the best split, then it will use only those features, those number of features. And of course, because it's creating different trees, for the first decision tree, maybe it picks the first 6. For the second decision tree, maybe it picks the middle 6. And if for the third decision tree, it picks the last 6. So it will randomly pick different features, and hence the different random forest will generate different decision trees, and each decision tree will be different from each other. And because the number of features which have been used to decide the best split in each decision tree is different. And in the samples used to create the decision tree are different as well. So max samples is 300, so sometime it will take the first 300, so middle 300, or the last 300, it will change. So basically the idea in random forest is we generate different decision trees which are different from each other, right? Okay, so then line number 7, we train the model. So we use dt_model.fit function, and if you hover over, it will just show you the the more description about what fit function does. We obviously fit it into the training. While fitting the model, we train it on a training data set. So that's why we give it X train, Y train. And once you have done that, your model is ready. So line number 7, your model is ready. Line number 9, what we are trying to do is we'll just see which values it predicts. So I'm just going to run this, and then I'm going to run this one. So what this way it has created the model and predicted some values. So what I have done is, for the first 10 rows in the training set, I've tried to predict the values. So these are the true values. So 24.4, 26.5, and these are the predicted values. So 23.73 and so on and so forth. And this is the difference. Okay, and same I have done with testing test data set. So dt underscore model dot predict, and I give it the first 10 rows of the test data set, and then I predict. And you can kind of see here that this is the difference in the testing data set, and this difference in training. So the error in training is less, like the first error is 0.66, but in testing it's quite big, so it's 2.26. And out here, what I do is I calculate the average error in the training and the testing dataset. So here I'm saying y-train, which is the values, the true values, minus a d model dot predict. So predict the training on the training dataset and predict the values. So this is y-train is my true values, and these are my predicted values. I subtract them, and then I take the average using numpy.absolute function. So I take the absolute value because sometimes the error will be positive, sometimes the error will be negative, and what we want to get is the true error. So we take the absolute value, and then we take the mean, and we do the same for the testing dataset. And as you can see, the training error is less and the testing error is high, and this will always be the case. Your testing error will be higher, and the error in testing is the true measure of performance of the model, because model hasn't seen the test dataset before. This you can I can run it to create different dot dot files, which are these. You can download these .dt files and then open it in Notepad editor, and then copy and paste it in this site, which is here. To view the graph is online. You can paste it here, and then it will generate a decision tree, which I have opened it here. So this is my first decision tree, and as you can see, it's LSTAT less than 4.91. If it's true, then it goes here. If it false, it goes here, and that way it keeps going, and then that's how it predicts the value. Okay, so that's a short introduction to the decision tree. And of course, if you change some of the parameters, then your output would obviously change. Let's say if I max depth, if I say 12, and the max features, if I say 7, and if I run it, then you will see a different set of values. And if I run the average error now, you would see different values. So 1.16, 2.28 again. So the testing error is higher, and then you can use this to generate the dot file, and then use the GraphViz website to visualize the decision tree. Okay, thank you very much.